Question 4 says, in figure 4, V1 is minus 2 volts. Sketch VO as a function of II over the range II is minus 3 milliamps to plus 3 milliamps. And the circuit we've got looks like this. Alright, so the question we have to ask ourselves as usual is, what do we have to do to put this diode on the edge of conduction, which is 0.7 volts across it and no current through it? Well, we've got minus 2 volts here and 0.7 volts, and they must add up to whatever's across the 2K resistor. So we've got 2 volts going that way, and we've got 0.7 volts facing upwards, so it's minus 2 plus 0.7 volts. We're using the blue, and then that, and the minus comes from the change of direction there. So this is, I call it V2K. And that will be minus 1.3 volts. So minus 1.3 volts across the 2K resistor will give us 0.7 volts across the diode. So we need to know what current that will be. So we'll have a current flowing down here like this. Now obviously if this is a minus voltage, we know that secretly the arrow's on this end, and that's plus if the arrow's down here. But I'm leaving the arrow up there because it's consistent with the arrow on the current source, because the current source is attempting to drive a current like that. And even if it turns out that the current goes the other way, we'll just end up with a minus sign, and then the arrows would be reversed. But we can keep the minus sign and keep our arrows, and it'll all be all right. So we'll say I is B upon R, which is minus 1.3 over 2K, and that will be minus 1.3 divided by 2E3 minus 0.65 milliamps. Minus 0.65 milliamps. Alrighty, so that's the point where something cool is going to happen. And what the question's asking us for is a graph of a certain range of I in. So we'll have this will be V out, and this will be I in, and it asks for 0 to minus 3 to plus 3 milliamps. So we'll have 1 milliamp, 2 milliamp, 3 milliamp, minus 1, minus 2, minus 3. So when the voltage across the 2K resistor reaches minus 1.3 volts, the diode will begin to conduct, and when that happens, it'll have 0.7 volts across it, and however much current it conducts thereafter, it will still have 0.7 volts across it. And for the voltage source, the minus 2 volts voltage source, however much current flows in or out of it, it will still have 2 volts across it in that direction. So when the diode is conducting, V out will be clamped at the voltage across these two, which will be minus 1.3 volts. And the current that needs to flow out of II to produce this point of clamping is minus 0.65 milliamps. So we can draw something on the graph now. So minus 0.65 milliamps is about here, and our output voltage will be stuck at minus 1.3. So we'll say minus 1.3 is just here. So that will be sort of minus 1, minus 2, minus 3, minus 4, and then we'll have 1, 2, 3 up there. So from, I should write minus 0.65, just there, and this is all in milliamps, and this is in volts. So we're going to have a line along here which represents our clamped region, and it starts at minus 0.65 milliamps from II, and the clamp happens at minus 1.3 volts V out. What about when it's not clamping? What if II is sufficiently less, a lower value, more negative than minus 0.65 milliamps? Well, what happens then? Well, the diode won't be conducting because it won't have managed to have 0.7 volts across it. Consequently, there is no clamping action here, and this pathway may as well not exist because the diode won't be conducting. So what we'll have is a current source driving a resistor. So we'll have, and the resistor is 2 kilo ohms, so if I had minus a milliamp, I'd have minus 2 volts. And if I have minus 2 milliamps, I'd have minus 4 volts, because we just apply Ohm's law, V is I times R, for the 2K. So in the case of minus 2 milliamps, I'd have minus 4 volts, so that would put me sort of about here really. And for the case of minus 1 milliamp, I'd have minus 2 volts, so that would put me out there. And for minus 3, I'd have minus 6, which is, well, 5 is probably about here, so 6 is probably about there, so somewhere down here, I guess. So that's broadly in line, so we're going to end about there, I should think. So it's a line that passes through those points, nearly, maybe, yeah, more or less. So the slope of this is slope due to 2K. There we go. So that tells you what that slope's about, and that's the solution. Alrighty.